Example 35.5. Combustion, combustion, and combustion. Formation. Now, not all combustion, okay? So you cannot simply use the equation. Calculate the standard enthalpy change of combustion of butane. First of all, it is our target. Highlight the target. You need to calculate combustion of butane. Change this statement into equation. Combustion of butane, C4H10 combustion. That means completely burnt in oxygen to form carbon dioxide and water. Next, 4 moles of carbon dioxide, 5 moles of water. Finally, 13/2 oxygen. This is the equation that you need to work out. Okay, it is the combustion of butane. Now look at the data given. Combustion, and formation. 2 of them are combustion and 1 of them is formation. Now I think it is better to solve the problem by using a cycle. Do not use equation, because for the equation, the data, this is the first equation. All the data given are combustion of reactant and combustion of product. For this, another one, formations of product minus formations of reactants. That means all the data given are formation. But now we have 2 kinds. 2 of them are formation and 2 of them are combustion, and 1 of them is formation. So now what to do is to change the term into equation. Combustion of graphite. That means graphite is completely burnt in oxygen to form carbon dioxide. Balance this equation, keep this as 1, then it is an equation. Combustion of hydrogen, which is 1 mole of H2 completely burnt in oxygen to form H2O. Keep these coefficients as 1, then we need half moles of O2. Next, formation of C4H10. Formation, that is the enthalpy change when 1 mole of butane is formed from its element. Its elements are carbon graphite and hydrogen, H2. Balance the equation, put 4 and 5. Convert all these terms into equation so that you can see how to relate them in a cycle. Okay, let's start. First of all, let's look at C4H10. C4H10, here we have the C4H10. Form from, that means we need to draw an arrow in this way, pointing upward. 4 carbon graphite and 5 H2. Do you understand? Label it as delta HA. Delta HA is the formation of 1 mole of C4H10. That means equal to negative 126 kilojoule per mole. Now, you must balance the equation. Now, in balancing the equation, we need 13/2 O2. It doesn't matter because 13/2 O2 changed to 13/2 O2. There is no delta H. No, delta H is equal to 0. I just want to balance the equation. Okay? Next, formations of carbon dioxide, formations of water. So I need to draw the arrow upwards. label it as delta HB. What is delta HB? Look at the arrow. In the arrow, we have 4 moles of carbon dioxide, or we have 4 moles of carbon graphite combust. Therefore, 4 times besides, we have 5 moles of hydrogen burned. 5 times, this is delta HB. Delta HB therefore is which is that is delta HB. Lastly, use Hess law. Again, can you identify which arrows belong to the same root? Delta HA and delta HC belong to the same root. Clockwise, clockwise. But for delta HB, anti-clockwise. It belongs to another root. In other words, delta HA plus delta HC is equal to delta HB. Delta HC therefore is equal to delta HB minus delta HA. Now substitute the data into the equation. Delta HB minus delta HA, which is negative 2877 unit kilojoule per mole. Can you follow? It is important, okay? Enjoying the cycle. Every time you need to refer to the definition.